welcome back to Little More Learning. Today, we will start with part 1 of metal joining techniques. In this video, we will cover the fundamentals of welding, the principles behind different welding techniques, and a detailed look at oxyacetylene gas welding and arc welding methods. Metal joining is the process of permanently bonding two or more metal parts, often using heat, pressure, or a combination of both. Common methods include welding, brazing, and soldering, each suited to different applications. Welding, in particular, is a widely used technique due to its strength and permanence, making it essential in industries such as construction, automotive, and manufacturing. Welding is classified based on the energy source and the method applied. Here are the primary types. Gas welding uses a flame from a gas fuel, like oxyacetylene, to melt and join metals. Arc welding uses an electric arc between an electrode and the metal to generate the heat needed for melting. Resistance welding relies on the resistance of metal to electric current, producing heat that, combined with pressure, joins metal surfaces. Solid-state welding joins metals without melting through pressure alone or with controlled heating, such as friction welding. Oxyacetylene welding combines oxygen and acetylene gases to create a flame with a temperature reaching up to 3,500 degrees Celsius, making it capable of melting metals like steel, aluminum, and copper. In this process, oxygen and acetylene gases are stored separately and mixed in a torch. When ignited, the acetylene burns in a controlled environment, producing an intense flame that can be adjusted based on metal type and thickness. The essential equipment for oxyacetylene welding includes cylinders, separate high-pressure cylinders for oxygen and lower-pressure cylinders for acetylene. Regulators control gas pressure as it exits the cylinders. Torch combines and ignites the gases, controlling flame size and intensity. Nozzles, different sizes for varying flame control based on the metal type and thickness. Protective gear, goggles or face shields protect welders from intense light and heat generated during welding. Oxyacetylene welding is widely used for its versatility and control. Applications: ideal for welding low melting point metals and sheet metals, especially in industries like automotive repair, plumbing, and metal fabrication. Advantages: it's portable and allows precise control over heat, making it suitable for delicate work or when on-site repairs are needed. Arc welding generates an electric arc between an electrode and the workpiece, producing intense heat that melts and fuses the metals. Different arc welding techniques are available for specific materials and production requirements, offering flexibility across various industries. Metal arc welding, or manual metal arc welding, uses an electric arc between a metal electrode and the workpiece. As the electrode melts, it deposits filler metal that forms the weld joint. Advantages: it's economical, versatile, and commonly used for structural steel, pipeline construction, and repair work. Carbon arc welding uses a non-consumable carbon electrode to create an arc between the electrode and the metal. It is especially suited for applications requiring high control and minimal spatter. Application: ideal for welding thin metal sections or parts needing a fine finish, as the carbon electrode produces a stable arc with precise control. Submerged arc welding uses a consumable electrode and a granular flux that covers the arc zone, preventing oxidation and producing high-quality welds. Applications: commonly used for heavy structural work, pipeline welding, and pressure vessel manufacturing. Advantages: the high deposition rate makes it ideal for automated, large-scale welding jobs. Atomic hydrogen welding uses two tungsten electrodes in a hydrogen atmosphere. The electric arc creates intense heat, up to 4,000 degrees Celsius, with hydrogen protecting the molten metal from oxidation. Application: ideal for high-quality welding of stainless steel and other heat-sensitive metals, as the hydrogen atmosphere reduces contamination risks. We've reached the end of this video. Thank you for watching, and don't forget to like and subscribe for more tutorials on other exciting topics.